History of Electromagnetic Theory, exploring the electromagnetic spectrum and the regions of electromagnetic spectrum. So what is electromagnetism? The electromagnetic or electromagnetism came from two words, electricity and magnetism. It is a branch of physics that studies about electromagnetic force carried by the electromagnetic fields. The electromagnetic field is liable for the electromagnetic radiation, such as light. In simple words, electromagnetism is the interaction of electricity and magnetism, the two important forces. What are the relationships of electricity and magnetism? The electricity and magnetism are related to each other. As we all know, electricity is the flow of charge carried by the electrons. It is the movement of electricity. Each electron is surrounded by a force called an electric field. The flowing of electrons produce a magnetic field generating an electric current to flow. Now that you understand the relationship of the electricity and magnetism, here's a brief history of electromagnetic theory. Hans Christian Ørsted, a Danish physicist born on August 14, 1777 and died on March 9, 1851. He discovered that electric current create magnetic field.
While he set up a wire electric current to demonstrate the heating effect of current, he accidentally put a compass to the wire. Notice that a magnetic needle deflects when the wire is connected to the battery.
He discovered that an electric current can create a magnetic field. This phenomenon established the relationship between electricity and magnetism. André-Marie Ampère, a French physicist born on January 20, 1775, and died on June 10, 1836.
He is a founder of science of electrodynamics,
now known as electromagnetism.
a unit of measuring electric current.
Ampere was named after him in his honor. He is influenced by Ørsted's discovery. He produced a magnetic attraction and repulsion without the use of any magnets, and all of it was generated by electricity. In his experiment, he set up two parallel wires. He made the electricity flow in the same direction to the wires, and the two had an attraction. But when the direction of the current is opposite, the wires had a repulsion.
Michael Faraday, an English scientist born on September 22, 1791 and died on August 25, 1867, the father of electromagnetic induction. He laid hold of the works of Ampere and Ørsted about the electromagnetic induction. It is a phenomenon of changing magnetic field into electric current. He set up a magnet and a solenoid that is made up of wire loop around to a hollow metal tube. The wire is connected to a galvanometer. A galvanometer is a device to use to detect the presence of electrical current. When Faraday inserted the magnet to the hollow metal tube, the galvanometer moved and the current is detected. But when the magnet is inside the tube and not moving, the reading in the galvanometer is zero. In contrast, current is only detected when the magnet is moving inside and out the metal tube. Therefore, a changing magnetic field produces an electric current.
Joseph Henry, an American scientist born on December 17, 1997 and died on May 13, 1877, by insulating the wire instead of iron core. He made the important design improvements while working with electromagnets in 1829. Though Faraday was the first to make the discovery and publish the result,
Henry also discovered the mutual inductance
James Clerk Maxwell, a Scottish mathematician born on June 13, 1831 and died on November 5, 1879. He predicted the existence of electromagnetic waves. Maxwell translated Faraday's theory into mathematical equations and he developed the electromagnetic theory. Maxwell is a scientist who contributed in developing equations that showed the relationship of electricity and magnetism. Means, he developed a scientific theory to explain the electromagnetic waves. He noticed that electrical fields and magnetic fields can be joined together to form electromagnetic waves. Maxwell concluded that the speed of electromagnetic waves must be 3 times 10 to the power of 8 meters per second, or it travels at a speed of light in a vacuum. Light to light is a form of electromagnetic waves.
Heinrich Hertz, a German physicist,
Born on February 22, 1857 and died on January 1, 1894. The unit of frequency was named the Hertz in the honor. A cycle per second is 1 Hertz. Hertz verified the theory of Maxwell that the electromagnetic waves travels at a speed of light. Hertz set up a spark generator for experiment coupled to an antenna and a metallic ring at some distance apart, and after the experiment he was able to generate and detect electromagnetic waves. For short, he is the one who discovered radio waves and specified Maxwell's theory.
Remember, electromagnetic wave is a transverse wave. The combination of electric and magnetic fields produce an electromagnetic waves because of the accelerating electrons. Both fields oscillate perpendicular to each other and to the direction of the propagating waves. Electromagnetic waves can travel in a vacuum at a speed of 3 times 10 raised to 8 meters per second, or 300 meters per second, and it is denoted as C symbol for speed of light. You can see that symbol in Einstein formula.
Exploring the electromagnetic spectrum. What is spectrum? Spectrum in plural spectra, it is the arrangement according to the wavelength of visible, ultraviolet, and then prepared lights.
It refers to the many types of radiation released from the stars, including sun. Electromagnetic radiation travels in waves. Frequency, the number of waves passing a point in a second. Meaning, it describes how many waves per second a wavelength produces. Wavelength, it measures the length of an individual waves in meters. Meaning, it is the distance between two consecutive crests or through of wave. Electromagnetic wave frequency corresponds to kind of light. It states that different frequencies of electromagnetic waves produce different kinds of light. But if the light is visible, the frequency is greater than this. It will exist as UV radiation, X-rays, or gamma rays. And frequencies less than visible light, it is qualified as infrared, microwave, or radio wave.
7 types of electromagnetic waves. First, radio waves, microwaves, infrared, visible light, ultraviolet rays, X-rays, and gamma rays. The different types of electromagnetic waves are defined by the amount of energy carried by the photons. What is photons? Photons, the bundles of wave energy. The gamma rays have photons of high energies and frequencies, while the radio waves have photons with the lowest energies and frequencies. For a visual example, the wavelength of radio wave is as long as the size of a football field, while the gamma rays is as small as the nucleus of an atom. For further explanation, we will discuss about the region of the electromagnetic spectrum.
The regions of the electromagnetic spectrum. Radio and TV waves have the longest wavelengths and the lowest frequencies. Can be produced by making electricity oscillate in an aerial or antenna, used to transmit sound and picture over long distances. Ang mga examples nito ay radio broadcasting, cellular networks, radar, radio astronomy, satellite communications, radio telemetry, navigation and air force control, magnetic resonance imaging, and submarines. Microwaves are radio waves of every short wavelength, used in satellite communications because they can penetrate the ionosphere. Ionosphere is a high concentration of charged particles. Ito ang mga examples: microwave ovens, GPS, Wi-Fi, Bluetooth, medical equipment, weapons, and military equipment. Infrared waves, waves that lie in the region beyond the red end of visible spectrum, are too long to be visible to the naked eye. Infrared radiation is most noticeable when given off by hot objects. Examples are remote controls. Uses of infrared waves. Infrared lights is even used to heat food. Sometimes special lamps that emit thermal infrared waves are often used in fast food restaurants. Visible waves. At about 700 degrees Celsius, the shortest waves present can be detected by the naked eye. These visible waves are what we know as light waves. Visible lights makes up only a small portion of the entire electromagnetic spectrum. When white light passes through a prism, it is separated into its constituent colors: red, orange, yellow, green, blue, indigo, and violet. Violet has the shortest wavelength, and red has the longest wavelength. Anything that glows or gives off lights makes waves of what we call visible light. Examples are television and computer screens, glow sticks, fireworks, and light bulbs.
Ultraviolet waves. Ultraviolet waves are invisible radiation that lie beyond the violet end of the visible spectrum. Ultraviolet waves has a shorter wavelength than violet light and carries more energy. The sun is our main source of ultraviolet light. Examples: sun, disinfectants, water purification, UV lamps, sterilization, and cure skin disorders. X-rays. X-rays have short wavelengths and high frequencies and are very penetrating. X-rays are produced by the rapid acceleration of electrons in X-ray machines that collide with atoms that emits X-rays. X-rays with long wavelengths are used in X-ray photography to help doctors look inside the body. X-rays with shorter wavelengths are used in industry to inspect welded joints or faults. All X-rays are dangerous because they can damage living cells and cause cancer. Examples: X-rays and standard computed tomography. Gamma rays, a high-energy waves that produce from nuclear reactions. Gamma rays has shorter wavelengths than X-rays because energy charges within the nucleus are normally much larger than those that take place outside it. Gamma rays are more dangerous than X-rays because radioactive substances emit them. Gamma rays can kill living cells, a fact with medicine uses to its advantage, using gamma rays to kill cancerous cells. Gamma rays travel to us across vast distances of the universe, only to be absorbed by the Earth's atmosphere.
In conclusion, electromagnetism is the interaction of electricity and magnetism. The scientists who made a very important contribution about electromagnetic theory are Hans Christian Ørsted, Andre Marie Ampere, Michael Faraday, Joseph Henry, James Clerk Maxwell, and Heinrich Hertz. Electromagnetic waves can travel 3 times 10 raised to 8 meters per second or 300 million meters per second, and it is denoted as c, the symbol for speed of light. The 7 types of electromagnetic waves are radio, micro, infrared, visible lights, ultraviolet rays, X-rays, and gamma-ray waves. Radio waves have the longest wavelength, but it is the lowest frequencies, while the gamma rays has the longest wavelength. It is as small as the nucleus of an atom.